seen the one method, that is variational method, and now we will just go for
छोटू
our next is प्लीज म्यूट कर लो छोटू, है ना?
सॉरी
ओके,
सर
थैंक यू। कोई बात नहीं, ठीक है, चलता है इतना, है ना? म्यूट कर लो। So I think everybody settle down. Okay, we should start this class. Okay, अभी लॉगिन नहीं हो रहा। Okay, again, good morning to everybody. So in the last class, what we have done, one beautiful method to understand quantum mechanical phenomena is the variational principle. So ultimate aim is that how you are getting the eigenvalue. This is the most important physical quantity we just want to find for any kind of system. So yes, we have seen one of the very basic principle of optimization in this variational principle, and then we started all about WKV approximation. WKV approximation is mainly influenced with the classical method or classical approximation, and it is mainly influenced with the Bohr-Sommerfeld theory. So where we can say that phase area under the phase space is quantized, but it has all other different type of intuition also. What is the intuition? The intuition is that whenever particle in the classical allowed region and it is bounded, we have sinusoidal wave and energy is discrete. And when we have unbounded, we have mainly in the classical forbidden region, we have exponentially decaying wave function, either in plus or negative side. This is our experience. So on the basis of this, WKV approximation give us a three different kind of boundary and three different kind of basically quantization rule. And this is mainly influenced with classical method, and we have done this type of calculation in the Hamilton, in this particular action angle principle. So we have done all this kind of situation. So the same type of integration is there, but the result will be little bit different because we are working with the quantum mechanical theory. So let's see how we will approach all this particular problem. Okay, so mainly we have talked about three kind of boundary. The first boundary is most famous. This will be your smooth boundary. I can say this is nothing but smooth. And the quantization rule here is closed integral p dx is equal to n plus half h, where n is equal to 0, 1, 2, 3, and so on. Second is rigid boundary. This kind of boundary is the rigid, and we have integration x1 to x2, and this will be p dx is equal to n plus 1 pi h cut, where n is equal to 0, 1, 2, 3, and so on. And this will be n pi h cut, where n is equal to 1, 2, 3, and so on. Either you can use all these things. Some books prefer this one, some prefers this one, but don't worry, in the examination they will just give you that which approximation uh, calculation you have to take. So main thing is how you are going to integrate all this concept, integrate all this particular thing. This is the main challenge. Everything will be given to your exam, so don't worry about this. And the third one is the one is rigid and another is basically parabolic. And again we will just go for x1 to x2. We have to just go for p dx is equal to, just we can go for n plus 3 by 4 pi h cut, where n is equal to 0, 1, 2, 3, and so on. Or you can write n minus 1 by 4 pi h cut n is equal to 1, 2, 3, and so on. So this is the three approximation method, and we can find energy eigenvalue. In the last class, I have used this one. Obviously, this type of boundary is only one boundary, that is particle in box. But yes, this type of boundary can be a number of boundary, and we can use this thing. So let's go for step by step to each boundary. So let's go for first smooth boundary. So what is the smooth boundary? The smooth boundary is all about, let's say, Vx is equal to half m omega square x square. This is the smoothest boundary we can see. Both side is well increasing when x is changing x to x plus dx. Smooth means continuously increasing or decreasing when x is going to change. So let's try to use this WKV approximation, and we will just figure it out whether what will be the energy eigenvalue. So obviously, what we have to do, we have to just write the expression of energy, and this energy is all about p square upon 2m minus half m omega square x square. So we can find the value of p, and that will be 2me and 2me minus half m omega square x square root under. So now we have to go for this integration. This integration is all about root under. So we have to write
Excuse me,
this
sir.
thing. Yes.
सर प्लस साइन आएगा ना पी स्क्वायर अपॉन 2m प्लस हाफ के
प्लस साइन प्लस साइन प्लस साइन प्लस साइन. सॉरी, यहाँ पर प्लस होगा, यहाँ पर माइनस होगा. सॉरी, दिस विल बी प्लस, दिस विल बी माइनस. ओके, kinetic energy plus potential energy. This is plus. So this will be basically p dx. What I can write? I can write this integration as root under 2m e minus half m omega square x square dx. So we know how to do this integration. Remember all this thing into action angle principle? We know easily these all concepts. Okay. So how do you know this? If you are just going to plot this potential is Vx. And if you are going to plot this potential is nothing for given value of energy. This is phase space, p versus x, and this will be elliptical in nature. Isn't it? So what we have to do? We have to calculate the whole area. We have to calculate the whole area. I am again repeating this thing. So how we will go for this calculating the whole area? The calculating the whole area is all about going to just we will go to this point and we will multiply with 4. Once we are going to calculate this particular thing and multiplying with 4, we can easily get the answer. So main target is how you are getting this number. So this number is nothing when p is equal to 0, and this is nothing but the boundary condition. So this is 2e upon m omega square to the power half. So remember, we have done this thing lot of time, not once, not two. We can use this thing at lot of time. So what do you have? You have 0, and you can multiply with 4 times. That will be 2e upon m omega square, and you have 2m e minus half m omega square x square dx, and we will take the root under of this. So now, what will be next target? Can anybody tell me how we will approach this type of integration?
सर 2m ही कॉमन ले लेंगे अंडर रूट 2m ही कॉमन.
Very good. We will make it dimensionless, है ना? We will make it dimensionless, and then we will substitute the particular thing. So what we will do? We will take root 4 2me root under 2me. I will take common, And now you can do it very fast. Okay. So that is 1 minus m omega square upon 2e x square dx. You will just go for 0 to 2e upon m omega square root under. Now, what you have to substitute? Now this is integration in dimensionless. You have to put one particular value. What is this value? So this value is m omega square 2e. Remember there is root. So we will take the root of this thing into x is equal to t. That's it. And now you can just put the dx is equal to, just we can put dx is equal to dt into root under 2e upon m omega square. So we can just use this thing, and when x is equal to 0, t is equal to 0, when x is equal to root t upon m omega square, t is equal to 1. So always we will try to write this integration as 0 to 1. So this will be 4 into 2me, and we will just go for, and you can take this number as dx as this number as 2e upon m omega square integration of 0 to 1 root under 1 minus t square. And here this 4 is not, this 4 is because we are just integrating up to this, and then we are using the symmetry. So how you will go for this integration? And dt is always there. So how you will go for this integration? We will put t is equal to sine theta and dt is equal to cos theta d theta. Okay. Or you can put t is equal to cos theta dt is sine theta d theta. That will be sine t is equal to 0, and this will be cos. So at this will be at pi by 2. So 0 to pi by 2 will be integration. So what you will get? 4 into root under 2me into root under 2e upon m omega square, and integration 0 to pi by 2. This will be nothing but cos square theta. So, so you will just go for 0 to pi by 2, and what you will get? You will get something cos square theta d theta. What will be this integration? We have done a lot of time. Can anybody tell me?
Pi by
What will
4.
be this integration? Pi by 4.
Pi
Very
by
good.
4.
So this value must be equal to n plus half h. So this is the value. So when we are doing this integration must be equal to, you can have this value is equal to n plus half h. So now we can easily get what will be the possible value of energy. So just after putting this value of integration, so I am removing this. We have done it lot of time, at least 2 and 3 times we have done this type of integration. Remember? So we have 4 into root under 2me into root under 2e upon m omega square into pi by 4 is equal to n plus half h. So now this 4 will cancel out. You have this m will cancel out. You have 2e into pi upon omega is equal to n plus half. Sorry, not h cut. This is h. N plus half. This is h. Not h cut. This is h. So you will just convert it h. So what you will get? You will get exact same value, isn't it? You will get exact same value. So E is equal to n plus half h by 2 pi into omega. And h by 2 pi is nothing but what? H cut. So you have exact value n plus half h cut omega. So this E will be, isn't it? So this is the energy. So this type of problem can come into your examination. I have deliberately taken half m omega square x square because we know the final result. So hence we know the final result. We can verify that whether this approximation method is useful or not. So now next question we will just go for next type of problems. So let's go for next problem. If you have any doubt, you can just ask me. Main thing is how you are approaching the integration. Approximation method is all about integration and differentiation, nothing else. In the variational method, what you have seen? You have seen how beautifully we can differentiate it and we can adjust the parameter. And here you can see how beautifully you can integrate the thing and you can get this particular thing. Once our course will over, then I will summarize the whole quantum mechanics in next 30 minutes. So let me give this time. Then you will feel that quantum mechanics is the simplest thing to use into the examination because there is n number of problem, but concept is well connected. So let's go for next problem. If you have any doubt, you can just raise the question. Okay, so let's go for next one. So next we have Vx is equal to infinity if x is less than 0 is equal to half m omega square x square if x is greater than 0. So this is nothing but the semi-parabolic. Okay, this is nothing but the semi-parabolic potential. This is all about half m omega square x square. So you have to use the WKB approximation and find the energy of this particular thing, and we will just try to figure it out whether it is correct or wrong. So what will be the value? Again we will go for integration p dx is equal to, let's say I am taking n plus 3 by 4 pi h cut. So this is n plus 3 by 4, but now here is h cut and this will be from x1 to x2. So this is all about the turning points. So for the given value, so this is potential. So for the given value of energy, we need to find what are the turning points. So this is the first turning point and this is the second turning point. So what is first turning point? X1 is 100% 0. And what is x2? We have to calculate the value of x2. So how you will get x2? Again you will write the value of energy. Energy is equal to p square upon 2m plus half m omega square x square, because my particle is bounded inside this particular potential. So only this potential is there, otherwise there is infinity, and this side is classical forbidden region. So this is the energy, and fortunately what will be the turning point? The turning point is where momentum is 0. So we will put momentum 0. I can get again this value of x or x2 as root under 2e upon m omega square. We can put the p is equal to 0 and we can get this turning point. So x1 is equal to 0, and when we will put p is equal to 0, then x2 is all about root under 2e upon m omega square. Very simple. Not any rocket science. The same thing we are doing again and again. Now, let's try to go for this integration. When we are going to this integration, then this integration will be between 0 to 2e upon m omega square to the power half, and this value is equal to the value of p we can write that will be root under 2m e minus half m omega square x square dx, and this value must be equal to n plus 3 by 4 pi h cut. So can I write this integration directly? Can I write this integration directly? We are enough smart. So you can write this integration as root under 2me. You will take this number as root under 2e upon m omega square, and inside this integration we have 0 to 1, that will be 1 minus t square dt must be equal to n plus 3 by 4 pi h cut, isn't it? So we can just jump directly and you can save the time. Now it is the best time that you can save your time, because we have done a lot of thing into classical mechanics, we have done a lot of thing into postulates. So what we are doing, we are just implementing all this thing we have done in the our previous classes. So I always uh, suggest people that initial classes is very important, because we are just implementing the same thing again and again. You will see that tomorrow class in the perturbation, you have nothing to do, you have to just implement whatever you have learned. So this is quite beautiful. So what will be this value now? What will be this value? Again pi by 4. So you can get this value is root under 2me into this value is basically root under 2e upon m omega square into pi by 4 is equal to n plus 3 by 4 pi h cut. Just a minute. Okay. So what we have, this m will be cancelled. So you have 2e upon omega. This pi will also cancel. And 2e upon 1 by 4 is equal to n plus 3 by 4 h cut. And now this will be 2 times. So we can just get this particular value of energy. So what is the value of energy? The value of E will be, we can easily find, and that will be n plus 3 by 4, and you can just go for 2 omega here. So that will be 2 h cut omega. You can multiply this thing with 2. So 2n plus 3 by 2 into h cut omega. And now we can verify. Here n will be started from 0, 1 to 3. So n will be go to 0, 1 to 3. So what will be the ground state energy? The ground state energy here E is equal to, we can find 3 by 2 h cut omega. And we have also analytically solved this problem in our harmonic oscillator. Remember all this thing?
Yes, sir.
Yes, sir.
Exactly same problem we have solved. You remember that I have told you that the mathematically this is the also wave function, mathematically this is the also wave function, but we will not accept this one, we will just go for this one, and this is the answer. Remember all this thing?
Yes, sir.
Yes.
Okay.
So again I am repeating, at least I am repeating it 5 to 10 times, how you are doing this integration beautifully. This is the most important thing, remember. Otherwise everything is simple cakewalk. Now let's go for next problem.
Excuse
And
me,
let's,
sir.
yes.
Sir, why didn't we take n minus 1 by 4 pi h bar here?
You can take. That will be same answer will coming there. You can take. Let me take this thing because
Yes.
confidence is very important. Let me take this one. So when we will take n minus 1 by 4 into 2h cut omega, isn't it? But what is the value of n? N will be 1 to 3. Remember? So once you will put n is equal to 1 to 3, the thing will be same. 1 minus 1 by 4 into h cut omega. So this will be, you will just 1 minus into 2h cut omega. So what you have? So n is equal to 1, then this will be again 3 by 4 into 2h cut omega. So this 2 and 2 will cancel, and again you will have 3 by 2h cut omega. Don't worry. Mathematics never change physics. Okay?
Okay, sir.
Okay.
Okay, sir.
Listen, this is nothing but the how you are writing n. And how you are writing n will never change the physics. The physics is here. This is the physics. But because I am giving you two different quantization rule, because different people have used different quantization rule. So why so? But both will give the same answer. The agenda is same. So there is not any problem. Okay. So let me go for our next problem. And this is, let me make it a little bit practical problem. Then we will try to solve it. Okay. So particle of mass m in gravitation potential gravitation field g. So I am taking this kind of situation. So how you will approach? So use WKB approximation. Use WKB approximation to solve allowed value of energy. Solve energy. So which kind of potential is there? So suppose particle is falling under the gravity. So obviously what is potential? The potential is gravitational potential. So let's say this potential is Vz, and that will be mgz when z is greater than 0. And by the way, what will be potential when z is less than 0? Because we have to define my potential from minus infinity to plus infinity. And what is 0? 0 is nothing but the surface of Earth. So what will be potential when z is less than 0? Is that your particle will, if you are throw the particle on the floor, is that particle will go beyond the floor?
Minus mgz.
Huh? Can it
Minus
will go to
mgz.
beyond the floor after? No, why minus mgz? I am just talking about particle come there and just fall down. That's it. What will happen? The ball will rebound, isn't it? The ball will rebound. So when ball will rebound? When you have rigid potential. आप कभी भी अपने बॉल को सरफेस ऑफ अर्थ के नीचे नहीं ले जा सकते हो. Never. So how you will interpret this thing mathematically? Means
infinity.
the potential is enough. That is infinity, exactly. So that is enough potential. Whatever be the energy of ball, it never will penetrate to the surface of Earth. What is meaning? it has infinite potential. So the potential for my system is given as basically infinity if I am talking about z is less than 0, and this will be z is greater than 0. So which type of potential is there? This is a wonderful potential. Straight line potential, mgz. So we are talking about pz versus z. Here is infinity, and this will be straight line mgz. So we have to use the boundary condition. Sorry, we have to use this WKB approximation to solve this problem. So what will be WKB approximation? So you have to go for P into Z day dz x1 to x2 is equal to one side rigid, another side is very much smooth. So we will go for, let's go for n plus 3 by 4 pi h cat. And solving this potential by the Schrodinger wave equation is the toughest task. This is very tough, even if this is single power. Even in fact, z square, the solving z square is easy from the harmonic oscillator point of view, but solving proportional to z is the tough task. So why we are using this particular potential here? So let's go for this. So what will happen? So again, we will write E is equal to P square upon 2m plus mgz, and yes, P is equal to 0, then Z is equal to E upon mg. Very simple. So P is equal to 0, then Z is equal to E upon mg. And now when we are going for this thing, so this is my x1 and this is my, sorry, this is my z1. I will tell you z1, and this will be z2. So this is my z2 and z1 is equal to 0. And now we will just go for integration. That will be z1, sorry, this is not x1 x2, this will be z1 z2, this will be z1 and z2. So we will just go for this integration, and this integration is all about 2m e minus mgz dz is equal to n plus 3 by 4 pi h cat, and n is equal to 1, 2, 3, and so on. And where to where this integration will be 0 to e upon mg. Now, can I write directly what should be my all value? कैसे कैसे approach करेंगे? So first I will take root under 2me, then you have this number e upon mg, and you have this integration 0 to 1 minus t dt. That's it. Isn't it? क्या क्या किया? You will take this one and put, जैसे ही इसको बाहर ले जाओगे, mg by e into z. So this is linear. So why linear term will be there? So what you will put? You will put mg by e into z is equal to t. This is the substitution. And now how you will solve this integration? Can anybody tell me? How you are going to solve this integration?
Sin theta put करके.
Yeah. Why sin theta put करोगे? It will make
Cos theta
more complicated. Huh?
Sin square theta.
1 upon 1.
Arre, just put it to 1 minus t is equal to z.
1 upon 2 root x.
Arre, why? 1 minus t is equal to z. That's it. This is linear. Why you are bothering about putting anything? If it is linear, then just put it that value. Isn't it? Look at here how it is work. So minus dt is equal to dz. So t is equal to 0, z is equal to 1, and t is equal to 1, z is equal to 0. So that will be flip, and this will be root under z dz with the minus sign. So what is problem? So please do integration very smartly. It is not needed that unnecessary you are just putting. Whenever there is linear integration in the any root 3 by 2. If this is the linear function, then put function is equal to z. Even if we can put this thing as a z without using this, you can put this thing as a z, you will get the same answer. So let's go for this integration. Root under 2me root under e upon mg, and we have this integration as 1 to 0 root under z, and again that is z. So put something else. Okay, put something else. Let's say put w or y. Let's put it y. Then this will be dy. So this will be root under y. This will be dy, and this is minus sign. And this value is equal to n plus 3 by 4 pi h cut. So this is the thing. Now, what will be answer? So you have root under 2me, not root under e upon mg. This will be e upon mg only. And this value is equal to y to the power half. What will be this integration? Y to the power 3 by 2 and 2 by 3. And minus minus will plus, so this will be 0 to 1. I can take minus, remove this thing, and this value is equal to n plus 3 by 4 pi h cut. So this value, isn't it? So you have 2 by 3 kind of situation. So you have 2 by 3, and you have 2 to the power half. You have m to the power 3 by 2 and e to the power half plus, sorry, m to the power minus half, isn't it? M to the power minus half and e to the power 3 by 2 is equal to n plus 3 by 4 pi h cut. And now you can put it all this thing here. At least you can find, I am just writing in term of proportionality, E is proportional to something n plus 3 by 4 to the power 2 by 3. Isn't it? Or in a very rough way, somebody can also write E is proportional to n to the power 2 by 3. This is constant. So at least in the proportionality term, you can put this value. So sometime they will ask you what will be the proportionality thing, that how energy is proportional to n. Not directly, not, you can also calculate the complete solution, but sometime they will ask you what will be the proportionality thing. And what is the value of n here? The n will be, you can just go for 1, 2, 3, and so on. So this is all about this problem, and you can easily solve what will be value of exact value of E. So you can solve with yourself. Okay, and now you can see. So how you will approach in the exam. So in the exam, you have to be very much smartly see this problem. If in a 4 option, suppose in this 4 option, you have, let's say, let me explain first, then you will ask. If you have 4 option and you will have some value, some constant into n plus or n plus 3 by 4 to the power 1 is half, b is n plus 3 by 4 to the power 3 by 2, and c is n plus 3 by 4 to the power, let's say, 2 by 3, and d is n plus 3 by 4 to the power 3 upon 2. Suppose this type of question will come into your exam. Means the power of n is different. Then it is the simplest question you can ever ask. Then what you will do? You will, let me explain you how we will approach this thing into exam. So suppose the power is different. The power of n plus 3 by 4 or n is different. Then you need not to solve all this step. you can just start from here. Let me explain you how I will go for this problem into exam, such that your time should be saved. Unnecessary calculation will be waste your time. Suppose this problem will come and there are 4 options. Then what I will do, I will directly go for this integration 0 to e upon mg, and we have 2m e minus mgz dz is equal to n plus 3 by 4 pi h cut. Now, if the power is different, what you will do? You will just take root under 2me into e by mg and proportional to n plus 3 by 4. Leave it, because the integration is just a number. You have make dimensionless and you have take this thing outside, and what will be this? Leave this all this constant term. E to the power 2 by 3 is proportional to n plus 3 by 4. So E will be proportional to, sorry, this will be 3 by 2. N will be proportional to 3 by 4 to the power 2 by 3. Without doing integration, I will go for this one. So where you have to do the integration and where you have to just go for the proportionality, it is very important. But yes, if in the examination every power is, suppose this is k1 and this will be 3 by 2, this will be also 3 by 2, this will be also 3 by 2. Let's say this is k1, this is k2, this is k3, this is k4. Then what you have to do? You have to just go for whole integration, such that now only k1, k2, k3 are different. So you have to go for this. So before solving, just see what are the 4 options and make your mind that, okay, I have to go for full calculation or I have to just go for this particular thing. Are you getting all this stuff?
Yes, sir.
Okay. So let's go for one more problem.
सर सर प्रोपोर्शनैलिटी के टर्म में अगर दिया है तो सर उसमें डायरेक्ट हम वो ट्रिक भी तो यूज कर सकते हैं ना
बिल्कुल बिल्कुल, वही तो मैं कह रहा हूँ।
जैसे v इज डायरेक्ट, मतलब v अगर x के कोई पावर में प्रोपोर्शनैलिटी में है तो हम e इज डायरेक्टली प्रोपोर्शनल टू n टू द पावर 2m अपॉन m प्लस 2 भी तो रख सकते हैं ना।
नहीं नहीं, ये सब आप कहाँ से रख सकते हो? ये कहाँ से आया फॉर्मूला?
सर उससे तुरंत
अरे जस्ट आ जाता है तो ठीक है, हो सकता है आपके पास कोई फॉर्मूला होगा। आई एम नॉट गोइंग टू फॉर्मूला, एक्चुअली आई डोंट रिमेंबर फॉर्मूला। ओके, सपोज vx is kx to the power 4 and e is proportional to n to the power alpha. Find alpha. I don't remember formula actually. Okay, find alpha. So what we have to do? Obviously in the 4 option, just alpha is going to change. So just we will go for, so v is equal to half the kx4 is something like this. So this will be kx to the power 4. And what we have to do? We have to just go for this integration because this is a smooth. So we will just go for pdx is equal to, let's say, n plus half h. And this integration can be written as 4 into integration of 0 to, we can find e is equal to p square upon 2m plus kx to the power 4. And then we can solve it, and you can solve this particular value. So you have this integration 2m e minus kx to the power 4 is equal to n plus 1 by 2 h, and 0 to this value is e upon k, and this value is equal to 1 by 4. So obviously this is given in term of proportionality, so there is no need to calculate this thing. So what you will do, you will 4 into root under 2me into we have E upon k to the power 1 by 4, and we have to go for this integration 0 to 1 minus t to the power 4 dt is equal to n plus half h. So this is the integration I can avoid in this problem. I can just avoid this problem. So what will happen? E to the power 1 by 2 plus 1 by 4 is proportional to n, and e to the power you can have 3 by 4 is proportional to n. So e will be proportional to n to the power 4 upon 3. That's it. 5 marks yours. And if you can fit it into any formula, it's your smartness. But I never try to pressurize my brain in the time of examination to recalling the formula. I can recall the algorithm, but using the exact formula is very tough in the examination. So there may be chance of error, but it's up to you that how smartly you can approach all this thing. Okay, so this is the first aim of WKV approximation, and the second aim is very interesting. When we are into the classical forbidden region, then we can also find what will be the probability. We can also find what will be the probability to find the particle. What will be transmission probability actually? This is known as transmission particle to find the probability within the region. So let's go for one or two problem. It is not even asked anytime into this examination, but we will prepare for this. So I will take next 10 minutes because I have started late. Okay. So let's go for that particular thing. So let's go for easily in this particular problem. So what do we have? Now, the story is very simple. What will be the transmission probability? Suppose we have this kind of situation or this kind of situation. Then what will happen? The particle will come and it will decay. So what we have to do? We have to calculate what will be the transmission probability in the classical forbidden region. And this is given as transmission probability is proportional to e to the power minus 2 gamma. And actual thing is that we have to just calculate this value of gamma, and this value of gamma is nothing but 1 upon h cut. You have to go for x1 to x2, and this value is mod p as a function of x dx. That's it. So we have to just again calculate one particular integration. And what is x1 to x2? This is nothing but turning point. X1 and x2 is turning point. So for example, I'm just going to figure it out some problem. So let's go for this problem. This is very interesting. Suppose this is my problem. And we have this potential is, let's say, V naught, and this will be 0 to A. So what we have to do? We have to find transmission probability between 0 to A, because this is the classical forbidden region. The particle will come here, it will decay here, and it will come there. So this will be the thing. Find transmission probability between 0 to A. We have to just calculate this thing. So what we have to do? We have to just find what will be value of gamma. So we will just write E is equal to. So here we can easily find the value of mod P actually. So not needed E. So what will be this particular value? So we have to go for gamma is equal to 1 upon h cut. What is turning point? X is equal to 0 and x is equal to a. So these are the turning point. You will just go for 0 to a. And what will be this particular value? This particular value 2m v naught minus e dx. Because we have to take the mod p. We have to take the modulus of this. So this will be v naught is greater than e. So you can just write v naught minus e. Remember in the solution of Schrodinger wave equation, we are using this type of trick. So this is something 2m v naught minus e. This is something k type of thing is there. Because if I will take h cut square inside, you will find this is nothing but the k kind of thing. This is constant, so don't worry. So this will be, you have taken root under 2m v naught minus e upon h cut, and dx integrated 0 to a is a. So what will be transmission probability is t is equal to e to the power minus 2 root under 2m e minus v naught. You can easily get this value. You can get e minus v naught into a. That's it. Over.
सर h क्रॉस भी आएगा ना सर 2 upon h क्रॉस.
H cut भी आएगा. 2 upon h cut is there. Or you can take h cut square inside. So I am just focusing on this thing. So what will happen? This will be root times something for the constant potential. It is very trivial. So first question is very trivial. Why it is trivial? Because this is just a constant potential and we know this particular thing. Isn't it? Let's try to go for some non-trivial problem where potential is function of energy. Sorry, function of x. Then how we will approach this problem? Obviously, the main task is how you are going to solve this integration. That's it. Nothing else. So let's go for this particular thing. So are you comfortable here? And if
Yes.
examiner will ask this question into exam, then he will ask the same question what I am going to solve. Don't worry. Because that should be the first question into exam. Let's say my potential is Vx is equal to 0 if x is less than 0 and is equal to V naught minus lambda x when x is greater than 0. And the for energy is between 0 to V naught, find transmission probability. Which type of potential is there? This is a wedge shape potential, something like this. If we will plot Vx versus x, this potential is linearly decreasing. X will be increase, this is decreasing, and this cutoff is V naught. So this is decreasing. And what will be energy? Energy is something like this. This is the value of energy. So this will be my x1 and this will be my x2. So what is value of x1 is equal to 0. So I know x1 is equal to 0. What is value of x2? You can easily find the momentum is 0. This is all about the turning point. When particle is coming here, the momentum is 0. So total energy must be equal to V naught minus lambda x. So x is equal to, we can find V naught minus E upon lambda. So this is the value of x2. So what we have to do? We have to just go for integration. We have to calculate the gamma 1 upon h cut. And we have to go for integration. That will be 0. And this is V naught minus E upon lambda. And what is this value? This value is inside bracket. We have 2m. And V is all about, we have to write Vx minus E because we have to go for this kind of situation. Isn't it? This is the value, and we can find the gamma is equal to 1 upon h cut integration 0 to v naught minus e upon lambda, and you will calculate this value is m v naught minus v naught minus lambda x. This is the value minus e dx. So we have to calculate this integration. How you will calculate this integration? Can anybody suggest me?
सर जो अंडर 2m b नॉट माइनस लैम्डा x माइनस
You
इक्वल
will
t लेके
take
चलेंगे
this
सर.
all thing as t because it is linear in x. You can take this all thing as t. So this will be linear in x. So let's try to go for this integration. What you will do? You will just take 2m v naught minus lambda x minus e. All thing I am taking as t. So when x is equal to 0, t is equal to. So when x is equal to 0, the t is equal to 2m v naught minus e. And when x is equal to v naught minus e upon lambda, so when x is equal to v naught minus e upon lambda, lambda cancel, then this will be x is equal to 0, this value is equal to t, and this value is equal to t is equal to 0, isn't it? And what is value of x? What is value of dx? So you have to calculate the value of dx. So dx is equal to minus lambda dx. You can write something like minus 2m lambda dx is equal to dt. So dx is equal to minus 1 upon 2m lambda dt. Now we can just go for this integration. Now this integration is cakewalk. Nothing else. Up to this, everything is okay. Just give me 1 or 2 minutes. I'm just completing this integration. So what we have to do, we have this integration as that value will be 2m v naught minus e, and here is 0, here is root under t, and there is minus 1 upon 2m lambda, and here is dt, and 1 upon h cut is also there. So let's go for this. And now this integration is very simple. This is minus sign, so there is not any problem. We can write 1 upon h cut, 1 upon 2m lambda, 2 upon 3 is there, and we can just go for 2m v naught minus e to the power 3 by 2, isn't it? That's it. So you have this 2 and 2 will be cancel. So we have gamma is equal to 1 upon 3m h cut lambda 2m v naught minus e to the power 3 by 2. This negative sign will cancel because I have taken this where. So I am directly writing this thing. And now what will be your t? Your t is equal to, let's say this whole thing is some alpha. So t is equal to e to the power minus alpha, and you have 2m v naught minus e to the power 3 by 2. So you can find that in the last problem, t is proportional to e to the power minus root under 2m v naught minus e, isn't it? And here t is proportional to e to the power minus 2m v naught minus e to the power 3 by 2. So you can easily see, as we are changing the potential, the transmission probability is also going to change. So every time you will not write this thing. You have to calculate what is the value of gamma. I am just talking about proportionality constant. And let's say this k is this alpha is equal to 1. I am not bothered about this thing. So main thing is that what will be this thing? This is e to the power minus 2m v naught minus e to the power 3 by 2. So this is the way you can just use this approximation method and you can find what will be the final answer. So what will be the basic understanding of this thing? They are classical thing. What is the meaning of classical thing? Classical thing means the particle have relatively less speed. It has relatively less speed and such that we can have means they have less momentum. Okay, smaller momentum के लिए आप बात करोगे, है ना? Less speed means less momentum means your wavelength of de Broglie wavelength will be high. So we are just talking about this kind of limitations into this into this WKV approximation. Okay, so this is the end of the second kind of approximation. So tomorrow we will just go for next approximation, that is perturbation theory, and this is the simplest one. So just you will see the class, look at this class very nice carefully. You will able to do the problem into your exam, because whatever we have done we will just go to replicate. I am not going to deal anything new, just we are approaching our problem from different method, but the concept we are derived from this our earlier experience of the solving Schrodinger wave equation. So if you have any doubt, you can just ask me. If you have any doubt, you can just ask me.
सर ग्रेविटेशन फील्ड वाला जो क्वेश्चन हमने किया था उसमें n की वैल्यू 1 से स्टार्ट होगी या 0 से स्टार्ट होगी?
जैसा आप पोटेंशियल लोगे उस हिसाब से, जैसा आप बाउंड्री कंडीशन ले रहे हो उसकी बात कर रहा हूं. अगर n प्लस 3/4 ले रहे हो तो n की वैल्यू 1 से शुरू करोगे, ठीक है, सॉरी 0 से शुरू करोगे. अगर n माइनस 1/4 ले रहे हो तो फिर आप 1 से शुरू करोगे, ठीक है.
ओके सर.
और आपको उसके बारे में चिंता नहीं करना. मेरा जो एक्सपीरियंस ये कहता है कि एग्जामिनर वो आपको दे देगा. अभी तक जो मैंने एक्सपीरियंस किया है प्रीवियस ईयर के क्वेश्चंस को, सारे 10 साल के अगर पेपर देखोगे तो जब भी WKV के प्रॉब्लम आएंगे तो वो इन जनरल वो कंडीशन दे देते हैं, बिकॉज डिफरेंट पीपल हैव यूज्ड डिफरेंट कंडीशन, है ना. तो जहां भी इस तरह की चीज होगी दे देंगे. तो आपको मिली इंटीग्रेशन पर ध्यान देना है, ठीक है.
सर हम लोग ने यहाँ पे एनर्जी इक्वल टू पोटेंशियल क्या है ना, वही कंडीशन हम लोग यूज करके W के भी सॉल्व कर रहे हैं ना अभी लास्ट
एनर्जी
प्रॉब्लम.
नहीं, एनर्जी इज इक्वल टू पोटेंशियल करके टर्निंग पॉइंट निकाल रहे हो.
ओके
ओके
ओके सर. ओके ओके.
लुक एट, आप याद मत करो चीजों को, ये आपका वेज है. दिस इज योर एनर्जी. एक टर्निंग पॉइंट तो सीधा सीधा नजर आ रहा है, पार्टिकल आएगा टकरा कर इधर चला जाएगा. क्लासिकली थिंक क्लासिकली. इस रीजन में तो आप क्लासिकली नहीं हो सकते हो. सेकेंड रीजन, the particle will come here and this is your turning point, this will be gone. So what is meaning of that? Energy is equal to potential. nahi?
Yes sir, yes sir.
That is the thing. We have done this thing lot of time, isn't it? When energy is equal to potential, when kinetic energy is zero, when kinetic energy is zero only at the turning point. nahi?
Yes sir, fetch कर में आपने बोला
fetch कर
था.
में बताया था. So listen, when I am discussing classical mechanics, I always used to discuss it that in the future I have to use it into quantum mechanics. Okay, so whatever we have done into classical mechanics, you can easily use into quantum mechanics very nicely. So why we can do this class into only 55 minutes? Otherwise, if you don't know how to solve this area under the phase curve, how you will get the turning point, it will take at least 3 hours. So we have make ourselves efficient in classical mechanics itself. Okay, so this is most important thing. So always try to correlate the thing. how you can get the advantage from your previous knowledge. You will see that tomorrow class, you have nothing to do, You will just see the problem and you will write the answer. You will see the problem and write the answer. Why we can able to do this thing? Because we have solved our one dimensional thing very nicely. We know our postulates very nicely. Then what we can do? We can just implement this. Just look at this problem and implement. And in this problem, what you have to do? You can just look at, implement this. Look at, implement this. Isn't it? And just 2-line integration. Okay.
Okay, sir. Thank you.
So
Excuse me, sir.
tomorrow, yes.
Sir, in last two questions, I'm confused about how we change the position of V naught and E. Like,
Because we are
sometimes
taking the mod X. Look at. Don't worry. It's a very simple, because we are taking the mod X. And if you are not able to understand this thing, then remember this one. Suppose your potential is minus h cut square upon 2m. If you are writing the Schrodinger wave equation, remember this thing. So why I am talking you that Schrodinger wave equation is, suppose I am writing this thing, okay? And if E is less than V naught, what you will do? You will write d square psi dx square plus, or you can write this thing is plus 2m E minus V naught upon h cut square psi is equal to 0. But E is less than V naught. So what you will do? You will just go for d square psi dx square minus 2m V naught minus E upon h cut square psi dx. And this value is all about gamma. Remember?
yes, sir.
So this value, so calculating this value. So once you are the calculating in this t is equal to e to the power minus 2 gamma, then what is gamma? This gamma is something integration root under 2m vx minus e upon h cut square. Let's say h cut square here. That's it.
Okay, sir.
Okay. So this is the same concept we are using, whatever we have done into the classical forbidden region. In the classical forbidden region, the Vx is always greater than E. So why I have deliberately taken mod P dx. Okay.
Okay, sir, got it.
Okay. Okay. So I am leaving this session. Tomorrow we will just go for. So tomorrow we have 2 classes of quantum mechanics. We will just go for perturbation, and up to Tuesday we will finish the perturbation in the 3 and 4 classes. Okay.